So very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches and class 6th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing chapter, that is the 6th chapter, magnetism. Today we are entering into the session number 5. So far we completed 5 sessions, 5 classes in understanding the basic concept of magnetism and applications of magnetism and many more terminology related to magnetism. So we'll continue where we left in the last class. And today we are going to learn some new things, how to prepare a magnet, how to get artificial magnet, what are the methods of preparation of magnet, and at the same time, what way you can lose the magnetic property, and what are the methods of removing the magnetic property, right? So before going for today's topic, so let us recall what we learned earlier classes, right? Then we move to the various methods to prepare the magnet. So as you all know, this is the basic history of magnetism. The picture completely shows how the magnetism comes, where it comes, who is the responsible for magnetism, which place we found the magnetism, and what is the material for the first material, which is called as a natural magnet. Everything is seen in the single picture. A shepherd named Mangrena, a place called Magnesia, a material called magnetite. So because of all similar names, the material is named as magnet and the property is named as magnetism. Okay. Then we have seen what is the magnetism, discovery of magnetism, and what are the types of magnets. There are 2 types commonly. That is, one is natural magnet, other one is artificial magnet. So natural magnets are okay. They are occur in nature in the form of magnetite or earth. There are only 2 natural magnets are there. One is magnetite, which is the ore of iron, right? It is also called lodestone. And the second one is our earth. Our earth is a big natural magnet, which has north and south pole, which has the property of attracting material and everything. But when you come for the artificial magnet, which are made by a man, this is we are going to discuss today. More how to get the artificial magnets. So artificial magnet means we can do any shape. We can prepare the magnet of any shape, whichever we require. It may be in the form of rectangle, it may be in the form of circle, it may be in the form of cube, it may be in the form of U shape, it may be in the form of ring or cylinder. Any shape we can prepare. So how to get that we'll discuss today, right? Then we have seen the magnetic needle or compass, which are used by the navigators to get the direction. Because as you know, the most important property of the magnet is showing direction. It always comes to rest towards north and south. It always shows north and south direction. That property leads for the magnetic compass or magnetic needle, which are used for knowing the direction either on road or water or in air. Only 3 possible ways of transport. Then these magnetic materials, the materials which are available based on how they are behaving with the magnet, they are classified into ferromagnetic substance, paramagnetic, and diamagnetic. So ferromagnetic substances are those which are strongly attractive a magnet and also can be used to make a magnet. Only ferromagnetic materials we can use to get the artificial magnets. Now we'll discuss. So artificial magnets can be prepared by ferromagnetic materials like iron, nickel, cobalt, and their alloys. Of course, some of the magnet can prepare from paramagnetic also because they are slightly attractive magnet. We can get weak magnets. Third category is diamagnetic, which are not affected by magnet or repelled by a magnet. So when you come to the properties of magnet, we have attracting property because magnet will attract magnetic materials. The property of attracting magnetic material is called attractive property of magnet. Directive property because it always shows north and south direction. So the property of showing direction is called directive property. Third one is inductive property. So you can convert the magnetic material into magnets without direct touch. See, example I'll tell. Simple example you can do practicals also. Take one magnet available with you, right? One pin you take, pin. A steel pins are available now. You take pin and attract here. So when pin is suppose any pole, north or south. A pin is attracted to magnet. Right. Then take another pin. The second pin is attracted to the first pin. Third pin is attracted to the second pin. Like this, you can attract up to certain level. But make sure, see here, what you observe is the first pin is directly in contact with the magnet. But second pin is not in touch with magnet. But still it behaves like a magnet. It is attracting third pin. Right. It is attracting third one. It is attracting the fourth one. So how it is they are behaving, that is called induction. Without direct touch also, they can attract the magnetic materials. Or they can behave like a magnet. Here second pin is behaving like a magnet. Because of that is attracting third pin. Fourth pin also behaving like a magnet. But when you remove this magnet, all pins will fall down. You can do this experiment also. Right? This property is called magnetic induction. Without direct contact also, magnet can convert magnetic material into magnets. Right? These are the properties of magnet. Then we have seen this theory also, molecular theory of magnet. That explains about the what is there inside the magnet. Why magnet is behaving like a magnet? Because of arrangement of molecules. In ferromagnetic substances, molecules are randomly or zigzag. They are in the zigzag way, right? Zigzag. Or you can call it as random. But after magnetization, suppose they are like this, irregularly molecules. Same, the arrow is a molecule. But after magnetization, after converting it to magnet by some methods I will tell today, they'll arrange like this. So whenever irregular molecules arrange in a systematic manner, align in a systematic manner, the magnetic material is converted into magnet, or ferromagnetic material is converted into magnet. That is explained in the entire theory. Then when you are heating the magnet, suppose the magnet is in your hand, heat the magnet for some time, it loses magnetic property. Because when you are heating this, suppose you are heating the magnet, right? What happens is molecules will get kinetic energy and they disturb. Again, they become like this. This becomes like this. So it loses magnetic property. Mishandling. You throw magnet here and there for a few days. It loses the magnetic property. Because the molecules will disturb. Cutting. When you cut the magnet into two pieces. Suppose you have magnet in your hands. One side north pole, other side south pole. You cut into half. We cannot get north pole separately, south pole separately. Again, we will get both as a, for example, this is the magnet we have. This is north pole, south pole, right? You cut into two parts. It doesn't mean that we get only North Pole separate, South Pole. Again, we get the South Pole here, North Pole here. Suppose again you cut it. Again, you get the North Pole, South Pole. Means if you cut the magnet into any number of pieces, 1 lakh pieces also, each piece with a small piece also, that piece will come with the North and South Pole. We cannot get isolated magnet like charge. Isolated means single pole. Still, there are so many experiments are going on to find out the isolated magnet from some hundreds of years. But till now, not confirmed. If you see in electricity, we can get positive charge separately, negative charge separately. But we cannot get the isolated magnets because magnet always exists with the pair of poles. That is explained by this theory once again. Okay, we learned about that. Then there are some, we have seen in the last class about the magnets, law of magnetism. Because you know that in magnet, there are some places where the total magnetic power is focused. The two ends of the magnet are called magnetic poles, right? Magnetic poles, where the total magnetic property of the magnet is concentrated. So in that, what they observed is when the two magnets are taken, like poles repulse, unlike poles attracts each other. Very important one. Like poles repulse, unlike poles attracts each other, which is called law of magnetism. What is called? Law of magnetism. That is also observed by the Greek scientists that time. Okay. So then more information about the some general definitions are given here. Okay. Like what is the magnetic length? Magnetic length is of two types. One is geometrical length. Second one is actual length. Geometrical length means you can measure the scale. Right. See here. I'll give one very important information. So this is called, suppose one scale is there with you, you can measure what is the length of the magnet from A to P, or A to B. This is called geometrical length. But what is the actual length? Actual length generally considered as from North Pole to South Pole, which is we cannot measure, but approximately given. The actual length is 80% of geometrical length. Actual length of magnet is always considered as 80% of geometrical length. If geometrical length is 10 centimeters, actual length is 8 centimeters. What is actual length? The distance between north and south poles of the magnet. It is not compulsory that north and south pole should be at extreme ends only. Maybe they may end here only, here also. That will come across in higher classes. There are some more theories are there, but you need to remember is actual length is 80% of geometrical length. Very, very important. And this length of the magnet is always represented by 2L, not L. L is not a magnetic length. Magnetic length is always 2L. That will come across again in higher classes. When you see the definition of magnetic moment, the formula is M into 2L. You can find out the magnetic moment of the magnet. What is the strength of magnet? Where M is called pole strength, strength of the north pole or south pole. 2L is called length. So when length is given, you have to consider 2L only. 2 into length you should not put it. That we can learn in 7th and 8th classes, right? So they're just basic definitions here, basic terms related to magnetism. So magnetic length, right? Now, when you come to the see, in this also, there are two important definitions again there. Equatorial line, axial line. There are two lines, axial line, equatorial line. Suppose we have one bar magnet. This is a magnet, north and south pole. A line passing through the north and south pole. This is called axial, along the axis. Along x-axis. A line passing through along the x-axis is called dividing the magnet into two equal parts. Same way, when line passing through the center of the magnet, like this, perpendicular to the magnet. This is called equatorial line. This is equatorial, this is axial. Along the axis, along the equatorial means makes the magnet into two equal parts perpendicular to the axial line is called equatorial line. See that the dotted lines are given. So about this also will come across higher classes. Now, today we'll discuss about what are the methods. What are the methods of converting magnetic material into magnet? That is, suppose you have iron is given for you or steel is given. How to convert that into magnet? There are different methods are there. Some of them are temporary methods, some of them are permanent methods. It may be single touch, double touch, electric, induction, so many methods are there. So before that is electric method. So before going for that, I'll show you one video regarding these methods. Then I'll give the explanation for you, right? See the video first, then we can go for the explanation about the methods of converting the magnetic materials into magnet. It is called magnetization.
Double touch method. Double touch method.
Double touch.
Place a steel bar to be magnetized on two bar magnets as shown here. Now place opposite poles of two strong magnets at the middle of the steel bar as shown here. Move the magnets towards the opposite ends of the specimen, keeping the magnets inclined. On reaching the opposite ends, lift the magnets and place them back to their respective original positions. Repeat the process. The polarities developed at the ends are opposite to the polarity of the pole used for magnetization. Place some iron nails on the table. Now bring the steel bar near the iron nails. The steel bar attracts the nail, showing that it has acquired magnetism.
Right? The steel bar is converted. See.
Introduction. Magnetization is the process by which a magnetic substance attains magnetism temporarily or permanently.
See. That is called
the methods used.
See. Converting magnetic material into magnet is called magnetization. So after magnetization, that may be permanent magnet can be prepared or temporary magnet. So methods you can see here.
Used to magnetize a magnetic substance are single touch method, double touch method, electrical method of magnetization. Demagnetization is the process.
So that is removing the property is called demagnetization.
Of removing the magnetic property of a magnet. The magnetism of a magnet can be totally or partially destroyed in the following ways: by rough handling, by heating, by induction, by passing electricity.
So please note down this. Magnetization, note down all of first. The entire screen you note down, then we'll move to the forward. What is the magnetization? What is the demagnetization? Preparing the magnet, destroying the magnet. Note down first. Quick, quick, quick. So, have you written? All of you. Sorry.